Here I am in Excel. I've inputted my data, and take a moment to inspect the format of these cells here. Notice that I only have numbers. There is no text, no letters in these cells. If you have something like meters after every value, Excel will not read those data as numbers. Excel will instead read it as text. We can't have that. We need to delete the meters, delete the text, so that Excel recognizes that these are all values. Okay, my data is looking good, but the column headers at the very top don't really fit because the columns aren't wide enough. Take your mouse, hover over the B at the very, very top, not below it, not above it, but right on top. Slide your mouse to the right, and at some point you see this two-arrowed icon with arrows pointing out. Once you see that icon, double-click with your left clicker on the mouse, and it auto-fits the width to match the text. Let's do it again over here. I hover over the C, slide my mouse to the right, and when I see that double-arrowed icon, I double-click with my mouse on my left clicker. Let's create a graph. Select all of your data, so move your mouse over the 85, left-click and hold, drag your mouse down to select everything, and notice how I have not selected the headers. You do not want to select any text, just numbers. Click the Insert tab at the top, find the Charts portion, and then click the button for Scatter Plot, which looks like two axes and a bunch of dots. Next, choose the first option from the drop-down menu, the one with no connecting lines. There's our chart. Let's add axis titles. Click this plus and check the box for axis titles. If you don't see that box, it could be because your graph is too far to the right and there's no room for the box to appear, the plus. Another thing that you can try if your box doesn't appear, zoom in or out, and sometimes that helps. So check the box, choose axis titles, and then let's edit these titles on the chart. Click the chart title once to select, then click a second time to enter the text box. Delete what's there or overwrite it, and we'll call this raw data. I click on the axis title once to select, I click a second time to enter, and then this is the x-axis, which shows my independent variable, the angle. Make sure you include units in parentheses. All right, I click on my y-axis title once, I click a second time to enter, and this is the x-axis displacement, or just the horizontal displacement. Okay, to save my work, I'm just going to click off to the side on my spreadsheet. We need another graph, but before we can make that graph, we need to process some data. The first step will be to convert these values from degrees into radians. And the reason is because when Excel does sine and cosine calculations, Excel requires radians. So right here, let's type out angle radians, and then I click enter on my keyboard. And now what we're going to do, we are not going to use our TI-83 calculators, or 85 or 86. We're not going to use those to do the calculation and convert these. We will do something much faster. We're going to tell Excel to do all of those calculations, but we'll only have to type out the formula once. Check this out. On your keyboard, click equals. That's right next to the backspace button. Every time you start a formula in Excel, it's imperative that we begin with equals so that Excel knows, hey, here comes a formula. Instead of typing out the number 85, hover your mouse over that cell and then left click. Again, I'm selecting the cell in column B, row 4, and now I have what's called a cell reference. Excel has B4 listed, but when it does the calculation, it's using the value inside of that cell, whatever value it may be. To convert this degrees value to radians, First, we divide by 180. So the divide button is the slash, which is the same as the question mark key on your keyboard. And then we multiply by pi. And for multiplication, you can click the star, which is Shift 8 on your keyboard. To save, click Enter. This is a good troubleshooting opportunity. Let's say that you accidentally enter this text again to edit, and then maybe you click off to the side somewhere you didn't want, and now we're modifying this formula, and that's not good. If you make some mistakes or you modify the formula and you want to undo, the easiest way, don't click away, oh no. The easiest way to get out of here is to just hit the escape button on your keyboard, which is the top left button. And when you click escape, it escapes from the cell and it doesn't save any of the things you've been doing. Okay, so why is Excel so wonderful and powerful? Well, check this out. If you copy this formula down to the cells below, it will repeat the calculation for all of these angles. Let me scroll down and click on this first cell. Right now we want to click on the cell, but we don't want to enter it. So if you accidentally enter the cell, just click escape on your keyboard, the top left key. I've got my key selected, my cell, and now I want to drag it down, copy it into the 12 cells below. So hover your mouse over the cell, and then move your mouse to the bottom right corner of the cell, and pretty soon you'll see this black crosshairs icon. Once you see that icon, click with your left clicker on the mouse and hold down, then move your mouse down until you've counted out 12 cells, and then let go. And check out what just happened. If I inspect this second cell right here, and I double click to enter the text, it's not using 85, it's using 80. That's the reference B5. And if I go down one, this is using B6 as its reference. The next cell uses B7. So it's performing the same calculation with every single angle, and I didn't have to repeat I didn't have to go through the process of typing the formula every single time. That is awesome. Now if I scroll down, you can see that I went too far, and I have some zeros because I ran out of angles and there isn't anything here. So don't hit backspace to delete, that doesn't really work so well. Instead, click the delete button, which could be above the backspace button, or on some keyboards it's above the right arrow, or the up arrow. Okay, so I clicked delete. Now I have to find the cosine of the angle, and then I have to find the sine of the angle. This text doesn't quite fit, so I'm going to use my trick. I hover my mouse over the D, I move my mouse to the right, and once I see that icon, I double click. Same thing here. Okay, let's type a formula that calculates the cosine of this angle. I type equals on my keyboard. Don't forget the equals. It's right beside backspace. I type COS, then open parentheses, that's Shift 9. Move your mouse over to the first angle and then left click. Close the parentheses with Shift 0. If you don't have the equals, this formula won't work. If you don't have the parentheses, this formula won't work. Make sure you've got both. Then click Enter on your keyboard to save. Now let me left click on this cell. Don't enter the cell. If you enter it by accident, just hit escape to get out. And then I'm going to use my trick where I move my mouse to the bottom right corner, and I could drag down, I could click and drag down like before, but check this out. Because there's already one column here, I can move my mouse to the bottom right corner, and once I see that icon, the black crosshairs, you can just double click with your left clicker, and it autofills the whole column down to this point. Let's do the same thing for sine. Make sure you have the equals, the parentheses, and make sure you choose the first angle in radians. Then click Enter on your keyboard. Move your mouse to the corner, select the box, move the mouse to the corner, and double click. Finally, we have to calculate the product of cosine multiplied by sine, and we'll just use that as our shorthand notation. So again, this is a formula, so click equals on your keyboard. Move your mouse to the first cosine value and then left click. Then, on your keyboard, click Shift star for multiplies by, and then left click with your mouse on the sine value, the very first value listed under sine. So now I'm multiplying the cosine value by the sine value, and then I click enter on my keyboard. I select the cell, I move my mouse to the corner, and I double click. Okay, the last thing we need to make a graph with the product of these on the x-axis, and then we need the displacement on the y-axis. So let's click and highlight this whole row, this whole column, including the text, and then we can, on our keyboard, hold the Control button down and then tap C once. Once you finish tapping C, you can release Control. Left click right here, and then hold Control again and tap V, as in vary, in order to paste. I'm going to move my mouse to the top, slide over beside the G, and double click to expand the width. Now I'm going to create a graph with these two columns, but remember, you don't want to select the text. Let's highlight just the values. I click on Insert, I find the Scatter Plot button, and I choose the first option with no connecting lines. Wow, look at that graph. Super straight, just like we predicted. I click the plus, check the box for Add Axis Titles, and we're also going to go all the way to the bottom, and we're going to check the box for Trend Line. I click once on the chart title, I click a second time to enter. We'll call this Processed Data. I click once on the axis title, I click a second time to enter. This we can simply call cosine multiplied by sine. I enter the y-axis title, and this is the horizontal displacement in meters. This x-axis has no units. And then the final thing is to double click on this trend line, and then make sure you've selected the 3 bars at the far right. At the very bottom, we want to check the box that says Display Equation on Chart. So let's go ahead and check that box, and then we can click the X right here to get out of this options screen. All right, there's my trend line. Moment of truth. See that slope right there? My slope is 20.511. 20.511. Let's use that value. The whole reason we set out to perform all of this Excel analysis in the first place was to produce this exact graph with this funny, weird thing on the x-axis that doesn't make any intuitive sense. Why do we put this on the x-axis? Because when we make this the x-axis, the coefficient to the x has acceleration due to gravity. In fact, because this is y and this is x, the whole thing has the form y-axis equals slope times x-axis. That's the equation of the straight line, and for that straight line equation, the slope is equal to whatever comes in front of the x. But now I know the value of slope. My processed data graph says the slope, the coefficient to x, is 20.511. So let me plug that value in right here, 20.511. I know what my initial velocity was. It was 10 meters per second for the experiment I conducted. I will now cross multiply by AG, divide both sides by 20.511, and I can calculate an experimental value of the acceleration due to gravity. When I hit enter on my keyboard, on my calculator, let's hope for 9.81. Hey, not too bad, negative 9.75. So that's my experimental value from the experiment of the acceleration due to gravity. Pretty cool. The last thing we can do is calculate our error, how far off the experimental value is, and then the percent error. The error is simply the experimental value minus the theoretical to see how far off you were. And in my case, I get an error of positive 0.06 meters per second squared. The error does have units. And then the percent error takes that value, that 0.06 that I was off by, and it expresses it as a fraction of the true value. So when I perform this calculation, what do I get? 0.006, and that's the decimal form. So if I want to, oops, it's already rounded. If I want to convert that decimal into an actual percentage, I move the decimal over, I multiply by 100. So this is 0.6%. And we are finished.